Good morning, guys. I am out today with my middle son, Dax Dowell. He dropped a board on his foot yesterday, and that board had a nail in it. So I thought we had his little cut under control last night, but it looked yucky this morning. So as you watch this, we are probably at the doctor. Hopefully not getting x-rays. So you just watched a video on the history of atomic theory. So that's all really important information, and we'll take time tomorrow to kind of recap that. But you should have completed the front of page 1 of your packet as you watch that. After this video, you will need to go backwards to the back of page 1 and complete that page. Just kind of processing what you were supposed to have learned from the video on atomic theory. So right now, though, we're on the front of page 2 of your packet. I'm going to introduce some very basic information to kind of get it out of the way. That way tomorrow when I'm back, we're not too far behind, because I do want to take time and go over atomic theory with you a little bit as well. So page 2, take these notes with me, and then again, when you're done, go back a page to the back of page 1 and complete that little chart, okay? So this is a symbol from the periodic table, and let me get this. There's draw. Draw with touch. Let's use blue. So this is a symbol from the periodic table. This is for the element carbon. And you learn throughout the history of atomic theory video that they kind of gradually discovered all the parts of the atom. You know, Democritus and Dalton were the ones who were like thinking of the atom. And then J.J. Thomson and Rutherford discovered things inside the atom, like the nucleus and the electron. So this is where we currently are in our understanding today of the atom. This is an element carbon. Let's label this with this word bank. This number right here, that 6, that is 2 of these words on this word bank are represented by this number 6. We call this the atomic number, and we also know that that represents the number of protons. Okay, that is an element's identity. If you look on the periodic table that you picked up today, or on the one on my table, every single element has a different number of protons. Carbon has 6. Nitrogen has 7, oxygen has 8, and that is always the case. Carbon always has 6. That's his identity, okay? This number is the atomic mass, and we will learn more about atomic mass later. Okay, I'm sorry, my handwriting looks like chicken scratch on the screen. We will learn more about that later. You won't really use that word again for a couple of days. Okay, the word that we are going to use for now is called the mass number. Okay, the mass number is not on the periodic table element symbols. Okay, the mass number is in every single element, every single atom. The mass number is the number of protons plus the number of neutrons. Okay, so that's the mass of a nucleus, basically, which is the mass of an atom. This atomic mass is the average of all of the isotopes, which we'll learn about another day, of an atom. Okay, so protons, guys, you need to know weigh about 1 AMU. They are so tiny we can't measure them with like grams and milligrams or even micrograms. So AMU is an atomic mass unit. Neutrons also weigh about 1 atm. So let's answer some of these questions down here at the bottom. The charge of a proton is positive, and it is inside the nucleus. I'm going to erase some of this so I have room. It's inside the nucleus. Okay. The charge of a neutron is neutral, so you can just write the number 0, or a really funky looking heart if you're doing this with a stylus pen. It's also inside the nucleus. Okay. Remember, the proton was Rutherford, and the electron was J.J. Thomson. The electron is negative. It's almost zero mass, and it is outside the nucleus. So in your nucleus, you have protons, neutrons, and then you have this electron cloud, just like this space with electrons in it. How are atomic number and number of protons related? They are the same. How do the number of protons, number of neutrons, and the mass number relate? Two typos in a row, that's annoying. Sorry, guys. Okay, they relate to each other because protons plus neutrons equals the mass number. Okay, remember we're not using the word atomic mass yet. Okay, I should have done that in a different color. Okay, what is the one thing that determines the identity of an atom? So that is whether it's an oxygen atom or a carbon atom. And that is the atomic number, which take a second and think to yourself, what does that represent? What subatomic particle does the atomic number represent? Its number of protons. Why are atoms said to have a neutral charge? So they're not always neutral. We'll learn that in a couple of days. But when they are neutral, it's because their number of protons equal the number of electrons. Okay, so for the time being, we're going to assume they're all neutral, and that's how you know how many electrons they have. So carbon has 6 protons. It also means that when it's neutral, it has 6 electrons. Oops. Come on. This is just ridiculous. This handwriting. What causes an atom to not be electrically neutral? If it loses or gains electrons. Okay? It can't lose or gain protons. If it does, then it's no longer that element, right? Because its identity is based on its number of protons. But it can lose or gain electrons, and they do that frequently. Anytime you have a compound created or separated or a chemical reaction, and that was part of those postulates. You know, atoms separate, combine, and rearrange to form chemical reactions. They are doing that when they lose and gain electrons. When an atom, number 9, is not electrically neutral, it is called an ion. Okay? And I learned on Friday with my pre-AP kids, that's some like abbreviation for I don't know, which is just silly. Number 10, many different atoms of the same element are called isotopes. And sometimes you might see the word nuclide used. Isotopes, if you can't read that, it says I-S-O-T-O-P-E-S. Many different atoms of the same element are called isotopes or nuclides. These atoms have different numbers of neutrons, but the same number of protons. Remember, you can't change the number of protons without changing the element. Okay, so that you can have various numbers of neutrons. And remember, mass number equals protons. I'm going to draw the symbol for proton, just P plus neutrons. Atomic number is also the number of protons. So that looks like a ton of notes, guys, but it was a lot of repeats, right? So let's scroll down. And this table is the bottom half of your page that we just took notes on. We're going to do this first row together, and then we will do some more of those tomorrow. So this is not your assignment for the rest of the day. Your assignment for the rest of the day is going to be the page before this, finishing those definitions. Okay, so anyway, the first row of this table I want us to complete together. So carbon, if you look at carbon's symbol, there we go. Okay, so carbon's symbol is C. His atomic number was 6, which means his number of protons was 6. We don't know the number of neutrons. Remember, on the periodic table, we did not have anything about neutrons or the mass number. So for these two columns, I have to give you either the number of neutrons or the mass number for you to figure this out. So if I'm telling you the mass number is 12, that means, remember, the mass number is protons plus neutrons. Okay, so if protons plus neutrons equals 12, we got to figure out our number of neutrons. We know we have 6 protons. So how many neutrons do I have? I have 6. If my mass number had been 14, I would have had 8. If it had been 15, I would have had 9. Okay, and again, we're going to practice that stuff together tomorrow. So now now try and figure out how many electrons it has. It's neutral. We're assuming that it is neutral. Oh my goodness. Assume it's neutral, and electrons should equal protons if it's neutral. Okay, so again, guys, now that we're done with this, we'll recap and process and review all this tomorrow. So now, go backwards, complete the back of page 1, where you are trying to match each of those definitions, 1 through 16, to a square in the box. Okay, don't stress about this whole magic number thing. But go for it if you think you can figure it out. All right, guys, have a good day. See you tomorrow.